Alright, 62 is a bacteria growth problem. So we're in a situation now where we're not in a half-life situation, so we can't just make K equal to what we thought it was going to be. Now it says the number of bacteria in a culture is increasing according to the law of exponential growth. There's 125 bacteria in the culture after 2 hours and 350 after 4 hours. So if we do a timeline, at t equals 0, it's going to be C. At t equals 2, there's 125. When t was equal to 4, there's 350, and we want to figure out what's going on at 8. So if we look at this as a timeline, this works out where we have all these different situations. When t equals 0, y is equal to c. When t equals 2, so we get the point 0c. From here, we're going to get the point 2, 125. From here, we're going to get the point 4, 350. And here we get 8, question mark. The thing is, we don't know K and we don't know C, so we don't know two different parts, right? So if you have two unknowns, how many equations do you need to solve for if you have two unknowns? Yes, you need two equations. So the number of equations has to equal the number of unknowns. Well, we have two different situations that we have to look at. The first situation is this situation. We can develop something here, and we can develop something here. Now, the easiest way to do this is to say, all right, for t equals 2, before I do anything, I want to say, all right, this is going to be CE. When t equals 2, it's going to be 2k, isn't it? And when t equals 4, y would be equal to CE to the 4k. Well, I didn't put in a y value. I do know my y values. So I know 125 is equal to CE to the 2k. And for this guy, I know 350 is equal to CE to the 4k. Now, what's the easiest? Since I have two unknowns, what's the easiest connection that I can make between the two? Is the K the easiest connection to make, or is the C the easiest connection to make? The K is up in the exponent of E. So it's kind of hidden away in the attic. The C is easier to access. Exactly right. So if I divide that by e to the 2k, I get C is equal to 125 over e to the 2k. If I do the same thing over here, what am I going to get for my C? Alright, so at this point, what do we know about C's? Are these C's different, or are they the same? They're the same, because remember, we're in a single situation, we're in a single system, where this culture started somewhere, and we know we're looking at here and here to help us figure out what happened at the beginning. So that C has to be the same for both of these conditions, because these two are part of the same timeline, of the same system. So these two C's have to be equal to each other. So 125 over e to the 2k has to be equal to 350 over e to the 4k. to show you, since this is probably a calculator problem, and we go into here, let me make a new one so it's a little bit more at the top. If you go to Menu, Algebra, and then Numeric Solve, and we set up the equation, and in this case it's a proportion, so I'll get 125 divided by e to the, that was 2k, well I'll say x in this case. And that's equal to 350 divided by e to the 4x. And then if I get out of here and go comma x, I figured out what my x value is, which is our k value. And what I'm going to do is I'm going to store this in A. So I'm going to go store, so control variable, put that into A, and now I have my k value. And the k value is really, 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 really big. So we got our k, which was equal to 0.51481. But I know in the calculator it's exact. So everybody okay with me there? That's the easiest way to do this. And since if this is a calculator problem, you can use these calculators on the test. And I would recommend that because of the storing feature. You can solve simple equations like this. May 5th. Alright, so we got this guy. Now I need to figure out what C is. Because part A says, what's the initial population of bacteria? Well, now I know what my K is, so I just have to take either this C or this C. I'll take the first one, 125 over e to the 2 times, I'm going to put A because that was my K in the calculator. So I'll jump back to the calculator, set up my fraction, 125 divided by e to the 2a power, and we got 44.6, but can we round it to probably 45? Yeah, we'll say it's about 45 bacteria. Alright, so I got 45 bacteria. Now, B says, alright, come up with a model. And the model is y equals CE to the KT power. So y is equal to if we just said, alright, 45, because you can't have like half of bacteria, so we rounded up to 45, we'll be okay. Or you could have used the actual number there. It wouldn't have been that big of a deal. And I just made the A, or the K equal to A, because that's what we had in our calculator. In a minute. Yeah. So B said, all right, do that. You could have figured out K was the 0.5. You could have said Y was equal to like the 44.68 blah 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 e to the 0.51481 t power. You could have come up with something like that. You still would have got the right answer for the next part. C says how many when t equals 8. So 8 hours later, what do we get? So let's go to the calculator again. And just to be crazy, I'll put the 44. Actually, I'll do this. I'll go control negative. So give me the answer from the first one. That's my C value, right? So I'll use the exact C value. Nothing wrong with that. Times e to the a times 8 power. And it gives us 2,744. So after 8 hours, we went we went from 45 bacteria to 2,744, and it's only going to get worse. So there's your answer for that one.